Isaac Newton's three laws of motion are more than just physics textbook material. They shape almost everything that moves in our daily lives. Whether you're riding a bike, driving a car, or throwing a ball, Newton's laws are in action. In this video, we'll explore each law of motion and how it applies to real-world scenarios, clearly, practically, and visually. Let's get started. First law, an object at rest stays at rest, and an object in motion stays in motion unless acted upon by an external force. When you're in a car that suddenly stops, your body wants to keep moving forward. That's Newton's first law in action, and it's why seatbelts exist. They provide the external force that stops your motion and prevents injury. Ever stood on a bus when it suddenly stops? If you weren't holding on, inertia would carry your body forward. That's why support poles and handrails are installed, to help counteract inertia. A soccer ball doesn't keep rolling forever. It stops because of forces like friction and air resistance. These forces overcome inertia and bring the ball to rest. In building design, engineers consider static loads. Objects at rest, scaffolding, bridges, and skyscrapers remain still because they're in a state of equilibrium unless disturbed by wind, earthquakes, or other external forces. Second law, the force on an object is equal to its mass multiplied by its acceleration. In athletics, Newton's second law explains how muscle force affects performance. A sprinter with strong legs generates more force, resulting in faster acceleration. When a plane takes off, its engines apply force to accelerate a massive object forward. Every kilogram of mass requires proportional force to lift into the air. When lifting weights, the more mass you move, the more force your muscles need to apply. This is a direct demonstration of Newton's second law at the human level. In robotics, Newton's second law helps engineers determine how much force actuators need to move robot arms or autonomous vehicles. It's essential in designing efficient, functional machines. Third law, for every action there is an equal and opposite reaction. When you walk, your feet push backward on the ground. The ground pushes back with equal force, propelling you forward. When you push water backward with an oar, the boat moves forward. That's Newton's third law, applied directly to motion. A rocket expels gas backward at high speed. The equal and opposite reaction pushes the rocket upward. When you jump, your legs push against the ground. The ground pushes you upward with equal force. That's what lifts you. Jet engines push air backward to create forward motion. This principle allows commercial airliners to travel at hundreds of kilometers per hour. Newton's three laws of motion describe how everything around us moves. From vehicles and sports to space exploration and human movement, they're fundamental to understanding the physical world. Whether you're a student, an engineer, or just curious, these laws are everywhere.
Enjoyed this deep dive into history and mystery? Hit subscribe and explore more fascinating facts from science, history, and the world around you.